Good morning, everyone. Welcome to St. Helens. The presentation today is experimentation and the gold standard of data champions. Our presenter today is Tim Chan. He's the lead data scientist at StatSig, and let's give him a warm welcome.
Thank you, everyone, for coming to my talk. I just wanted to give a thanks to the organizers, PyData, and all the volunteers. This is a wonderful event, and I hope you folks get something out of this. My name is Tim. I lead data science at StatSig. Prior to StatSig, I, like many folks who are data scientists, did not start out as data scientists. I have a PhD in chemistry. I worked in the biotech industry for many years, was sort of familiar with how that sort of field of does experimentation. But for the longest time, I wanted to merge science and business. And what I really wanted to do was use scientific principles, use data and the scientific method to make sound business decisions, because I felt like I saw too many times in business conference rooms, people getting up there, putting on shiny presentations, coming up with great stories, and that's how decisions were made, whoever had the most compelling argument. And there wasn't a lot of facts behind it. And so that's sort of what led me on my data science journey. I spent 5 years at Meta. Back then it was known as Facebook, where I did a lot of experimentation. And then I joined a company called StatSig when it started 2 years ago. And you'll learn that we are very much focused on experimentation and helping our customers make proper business decisions. What I'll share about, though, is not a sales pitch. It's really what we have learned from leading tech companies on how they approach and build experimentation platforms, how they're able to run 10,000 experiments simultaneously, and how they become data-driven organizations. I'll share a lot of their best practices. These are applicable for your companies, whether large or small. And you're going to see how this really democratizes data, which is something which I hope everyone in this room really hopes and wants to drive towards. And what I've seen experimentation do, a good program, is it really can accelerate the pace of innovation at your company. And lastly, I'm going to share a little bit about personal advice for being the data champion as well. But first, I'll just take one slide to give a brief introduction about StatSig and who we are. We've put on the slide here, we're a modern product observability company. That's a mouthful. You can think about it as we provide analytically aware engineering tools. So basically smart engineering tools. And these are based, we're not inventing the wheel here. These are based very much on the same tools that power product teams at leading large tech companies, many of which you will know of, such as Facebook, Google, Microsoft, Airbnb, Netflix. The core of this really is feature flagging and experimentation. Feature flagging is how you release features to users. Experimentation is how you watch what happens when those users get those features. Just some quick facts. We're just 2 years old. We're founded in 2021 by a team of ex-Facebook product builders that believe very much in data-driven product development. We're based right here in Bellevue, so we're local, and we've grown rapidly. We're already actively being used by many fast-growing startups, such as Notion, Ancestry, Figma, Headspace. And we're currently serving insights across hundreds of products, thousands of experiments, and if you add up all of those users in those experiments, it adds up to more than 1 billion. I will start from the product analytics hierarchy of needs, just to sort of frame where experimentation fits here. User analytics is the foundation of all product analytics. It's really just about understanding your users. If you're starting from ground zero, it requires defining your KPIs and starting to measure them. But it can go way deeper than that. You can get into understanding funnels, understanding user journeys, drivers of retention, building LTV models, et cetera, et cetera. This is a big field. And while most of these are all great methods, and I love them all, to me, my favorite and the one that is the most powerful is experimentation. It is the most important tool in the product analytics toolbox because it is the gold standard for causality, really understanding what changes cause which effect, not just correlation. It is most popular in the field of website optimization, which has largely been the domain of marketing teams. And the focus there is on understanding and optimizing tactical metrics. Things like click-through rates. I want to make this button be a little bit more prominent. I want users to see it. I want them to click through. Things like I have a sign-up form that has 7 steps. How did I get them to complete it? That is what website optimization is. But now there's a field that's emerging of product experimentation that's starting to become pretty popular. And this is where we're doing experimentation on things that are a little bit more complicated than just click-through rates. Because products are complicated. Things like the Facebook app are complicated. Things like Amazon are complicated. And in order to do experimentation here, you want to understand the big picture. You may be responsible for just the conversion of users adding items to a cart. But what does that have for downstream teams? What does that have for other teams that are adjacent? This involves understanding more metrics, deeper metrics, business metrics ideally, and also longer-term outlooks. Like you want to do more than just a session. You want to know, is that user, are they retained for the next month, 2 months, maybe a year? And then even within this field of experimentation, big tech is once again leading the charge, and they're doing this far differently than everyone else. They're doing what I would call ubiquitous experimentation. This is like 10,000 experiments simultaneously being run across many, many different teams. The focus here is on driving velocity, on the number of experiments you run, because experiments are how you invent things. It's how you test ideas. It is your pace of innovation. At least that's what these companies firmly believe. But I'll zoom back a little bit out and just focus like what is an A/B test and why would we even do it? A/B testing, as I mentioned, is the scientific gold standard for understanding and measuring causality. You essentially have 2 groups of users, an A and a B, or a test and a control, that are fairly equivalent. Usually you identify these 2 buckets of users, assign them by randomization. You keep all things equal on their user experience, and you make just one single change, a treatment, so to speak. And then by measuring those users and comparing them, the test to the control group after the experiment, you can any differences you can then assign to that's what happened because of your treatment. It's best known in clinical trials, and so you might imagine like I want to cure this disease or address the symptoms. You can actually tell that, but not only that, you can also measure the safety of the drug. Did anything else happen that was unexpected? This is very much aligned with how product testing approaches things. We can validate whether these improvements we're making to our product are actually causing the desired effect on our users, and also can identify the side effects, what might have happened that we didn't anticipate. But the meat of this really is that in product experimentation, we can actually just measure and validate ideas. It's actually easier to test and iterate on ideas rather than design them perfectly inside a conference room. Because we're building these products and we're evaluating these ideas using real data from real users. Product development now becomes a scientific and evidence-driven process. And the funny thing is once product teams start adopting experimentation, there's actually a cultural transformation that happens here. Decisions stopped becoming about opinions and stopped becoming about convincing people with a compelling argument. Data wins arguments here. And so I think you'll notice that we have a booth outside where we're giving out Hippo candies. HIPPOs is an acronym short for highest paid person's opinion. And that's how business decisions used to be made. And we're advocating for you can eat the hippo now and win with data. Teams become hypothesis-driven. And it's amazing how scientific principles start to come into play when you start adopting experimentation practices. And experimentation, my favorite part, is exceptionally humbling. There's many times you will firmly believe that this idea is going to work, and seeing the actual experimental results, either that it didn't work or that the effect was far smaller, actually helps hone your product intuition. In the world of experimentation, there's a lot of ideas out there. Actually, just in the world of product development, there's a lot of ideas out there. And unless you're Steve Jobs, people do not have a great batting average when it comes to designing products or coming up with ideas. In fact, the majority of features we build actually fail when you test them and measure them. Google and Bing state that only about 10 to 20% of their experiments work. And Microsoft as a whole published this analysis that said that about 1/3 of their ideas had the desired impact. 1/3 of them did not, but they could still iterate and fix it to make them good. And then 1/3 of them are actually negative. These are features we should just cancel and turn off and get rid of. You can think of this as like once you're actually able to measure these ideas, you're now able to stop the features that are red. You're able to improve the ones that are gray, and you ship the blues, and you book those wins. Now, for your company, you may not be a Microsoft or a Google. The batting average will vary depending on your size and maturity of your product. And we have found that with our customers that actually early stage companies have a huge advantage in the realm of experimentation. They have actually higher success rates. There's more low-hanging fruit. These are usually under-optimized products that aren't following best practices, and sometimes in a rush to get an MVP out the door, it was just important to build something, and now you can go back and actually test what happens if we start making improvements. So they'll usually have more blues and less reds. But still, just blocking those reds is usually a big win for your company already in terms of like its progress to making a good product. And another secondary effect here is like once you're actually able to measure the impact of the features, this pie actually grows. Because now you can because you can tell which features are good and which ones are bad, you don't have to be careful about building features anymore. You can actually test even more ideas with the confidence to know that you'll be able to identify those winners. Now, what if we say we're data-driven, but we don't experiment? And the traditional way is you say, like, listen, we have metrics, and we follow them on dashboards. And we want to know what happens. And for everyone who's been a product data scientist, you've come into work, and you've seen a metric on your dashboard suddenly go up or suddenly go down. And you have executives that come up to you and ask you, what happened? And you play this game of like, OK, what did we do? What did we change? What might be going on in global events? You ask teams around you, what did they know? And you start putting together a really good story. And this is a chart of the S&P 500. It has lots of ups and downs. But this could be a chart for any company. For example, if this was revenue for Amazon, this could be it. And my favorite thing is like the S&P 500. If you were to tune into like business news at the end of the day, the folks on TV or the folks in those journalists have perfect explanations for what happened today. They're great at explaining with high accuracy, but they can't predict anything that's going to happen tomorrow. And so same thing happens when you're looking at your own company's dashboards. And I call this reading the tea leaves, because sometimes you see what you want to see. And you actually have a lot of trouble actually understanding what's actually going on for real. There's a lot of noise. Some of this is internally because your products are always changing, your users are always changing. Some of this externally, your competitors could be up to things. But with experimentation, the key here is that comparing your test group versus control group controls for a lot of those factors, those externalities, which is why we're able to get high precision. And so pretend this is your revenue chart, which is the S&P 500. I have injected in here a 10% lift to your revenue that's over 10 days. 10% is a really big deal for any company. And you would hope that you'd be able to see it in this dashboard, right? Where is it? Is it at that peak? Is it happened right at the bottom when it starts to recover? I picked a random day, and that is actually today, but exactly 1 year ago. And you can see here that that would not have been one of the ideas. You would not have known that 10% improvement came in right at the end of April, because you can't see it, because day-to-day variability is high, week-to-week, month-to-month. And all top-line business metrics tend to look like this. And 10% is like a pretty material difference. The fact that you couldn't even pick that up in a dashboard means that like this is not the way to understand the impact of your features. Now, with all that I've shared about experimentation, we still find that even companies that are adopting this aren't really doing it fully at scale. There's still a lot of problems in experiments. And at most companies, A/B testing is really only done on a very limited set of features, really only the tip of the iceberg. And why? Because experiments at these companies require a lot of heavy lifting. It requires a lot of effort for engineers to set up the experiment, to assign the users. You need to make sure that the experiment is working. Are your groups properly balanced? Are you logging exposures? Are you logging metrics correctly? And then when you do the analysis, which I think folks in this room can relate to, this is exceptionally tedious and time-consuming, actually, to be able to compute experimental lifts for test and control across possibly dozens of metrics. What this ends up being is this process becomes highly error-prone, often done ad hoc, Every single time a new experiment comes through, a new process is invented. People don't trust the results for that reason, and very few things actually end up getting tested, which is sort of sad. But when you look at the companies that are doing it correctly, they are actually doing something called product observability. They are measuring and testing every single change that goes out to users. And I saw this very much at Facebook as well. Experimentation actually is no longer the domain of just data science teams. It becomes standard engineering best practice. It's an engineering tool. And just like unit testing your code, adding QA, adding monitoring, and tracking error rates, experimentation is just another step in knowing that your code works. And I'll share an anecdote. When I was a data scientist at Facebook, an engineer showed me he did a one-line code fix. Very obvious typo in the line of code. And he's like, I'm just going to fix this typo. It's like, do I really need to put this behind an experiment? And I thought about it. I was like, well, this obviously works because there was a typo before, and you fixed the typo. But I thought about it, and I said, well, what's the harm in doing a 2-day test? I was like, there's no cost in setting up an experiment at Facebook because the infrastructure was there, and it's trivial. He just had to go and turn on the tooling. And so he did that. And he found out, we were able to see very clearly after 2 days that he fixed the bug he was intending to fix. We also found out that downstream, another bug was introduced. So, and everyone knows who does coding is like sometimes you fix something here, you have a problem down here. That was what was happening to Facebook's users. And we would have only been able to pick that up through A/B testing and being able to A/B test even trivial changes. That is really the power of what happens when you start to test every single change and when experimentation becomes an engineering tool. This brings us to something which I would call modern experimentation culture. And so experimentation at this pace and scale actually changes a company's culture. They become more data-driven. There are parts of this. I've explained experimentation. I'll explain the modern part and the culture part. It's modern because in today's world, products are complicated, especially in the level that we understand how users engage with them. Experimentation is more than understanding a single metric. It's understanding the full ecosystem impact of your changes. I'll give an example. If you're YouTube and you want to change how ads work, you understand that you will possibly drive up revenue, but it may come at the cost of user engagement. Is that important for you to understand? You bet it is, because if that engagement is not favorable, it's not great for your product. So there are often trade-offs, synergies that happen. Another example is like if you're Facebook videos and you want to get more video content on the platform, is that going to affect how you interact with your friends and family? And is that what Facebook should be doing? You'll want to understand longitudinal effects. Are these effects and changes you're seeing just novelty effects? Or are they actually durable? Will they last the month? Will they last to the next year? In general, you want to understand deeper and more meaningful metrics. Culture. Culture is all about, at these companies, is all about velocity. It's all about your pace of innovation. It's where data is democratized. It's accessible to PMs and engineers, not just data scientists. It becomes pragmatic. It's not about the complex stats. It's about making it interpretable, understandable, and actionable when you see results. These teams that do experiments start to become metrics obsessed. They start to share information between them. Data becomes king, and opinions actually don't matter as much anymore. Now, you're thinking that these companies on the right, the Spotifys, the Facebooks of the world, like what they're doing is not applicable for me. And that's actually not true. There's many steps on making your company better and more data savvy and more experimentation friendly. And we call this the walk, jog, run, fly framework. And no matter where you are on this, there's benefits to tackling your current challenges and trying to up-level your organizations to the next level. And I just want to sort of acknowledge that this is a cultural change. Cultural changes at companies are hard to do, but experimentation is an exceptionally powerful lever to get folks to start really understanding the power of data and how to make decisions. And now I'll talk about my favorite slide, which is that stats engines don't build culture. We have a lot of customers that come looking to replace their statistics engine, looking for an experimentation tool. And if it's a data science customer, the focus is usually on the left. They're focusing on the stats engine. They're asking questions like, are you Bayesian or frequentist? Do you support the Mann-Whitney U test? What about multiple comparisons? What level do you windsorize, and how do you know that's good? These are all important questions, I won't deny, but it actually misses where we see experimentation programs fail. Experimentations fail when you're not able to drive proper experimentation culture, when you don't even have metrics being plumbed in correctly, when you are having a hard time setting up experiments, where setting up an experiment is your bottleneck. It's the hardest thing to do, and it's not coming up with the ideas. And you are not testing every single change. That is the harder part. And so that's why I'll share sort of the experimentation best practices. There's many books and blogs out there that do a really good job, and I can recommend them if you want to come talk to me. But one thing that we have done as a data science team at StatSig is we spend a lot of time speaking with experts in the field. These are folks at top companies such as Netflix, Spotify, eBay. They're doing a lot of experimentation. And what we found was a lot of the practical aspects of experimentation are actually locked up and not published. And there are a few common themes, which I'll share here. It's like number one, I've said we need to make experimentation really accessible. Experimentation should be a team sport. It should be standardized and not gatekeepered by the data science teams. You should have standardized methodologies in place. It's really important to have really good defaults that apply across your company's set of experiments. But the reason why you should standardize and not customize it for the task at hand is that it makes the results comparable across your org. If team A claims they lifted revenue 2% and team B claims they lifted revenue 3%, you know we're actually comparing apples to apples. They're using the same definition of revenue, calculated the same way. These results now become trusted when you're not customizing it, which removes an important source of bias. They're all using the same metric source. Things are consistent, reproducible, and reliable. Holdouts. Holdouts are super important to just understand what is happening. You usually have a set of users that are not receiving all the changes your company is doing. You can start understanding, like, are we actually making good decisions? If everyone is calling everything a win, do we actually see that in the long term? I'll dive into a few of these things that are my favorite. This is a picture of the StatSig console, but it's more just to highlight and illustrate what I would call the progressive disclosure of complexity. I will acknowledge that statistics is complicated, and in order to make it approachable and intuitive, you have to make it look like a dashboard and make things easily understand. But yet you still want to make sure that all the complexity and nuance of statistics is still there somewhere. And so this is what we show. We show usually test versus control. So these are lift. And when something is statistically significant, we color that lift with confidence intervals in green. When something is negative and significant, we color in red. And when it's ambiguous, i.e. the null hypothesis is not refuted, we put it in gray. This is really easy to understand. It's really accessible. But data scientists will definitely want to dive into the details, really understand the assumptions in here, understand the nuances of the data, maybe understand a little bit more what goes into those numbers and calculations. So we do something called the progressive disclosure complexity. If you hover over any of these, we show you a scorecard. It surfaces a few more metrics, such as if this is a sum of total purchased dollars, we'll actually show you what actually dollars were triggered by the test group, what dollars are triggered by the control group. If you wanted to go into further, we actually provide a whole array of different metrics in that view details card. For example, this one's my favorite chart. It's a days since first exposure. You can actually understand that sometimes when a user sees an experience on day 0, they will have a certain reaction to it. Sometimes it's favorable. For example, brand new shiny pink button that has unicorns on it. Great, I want to play with this for a little bit. But then maybe after a week, it gets boring, and then that effect starts to wane. Or is it possible that the new feature you've shipped actually drives engagement long term? You can actually sort of see that as it sorts of lifts over time. This gives you a little bit more nuance on what's going on. This is probably my most controversial take, is that people think experimentation is only in the world of large companies. You need millions of users. From the experience, and for example, Bing has shared a long time ago a 50 Shades of Blue experiment, where they were trying to tune the color of blue on their search engine. This is something which you absolutely need millions, if not hundreds of millions of users for. But the secret of big tech is that they use the same tooling they do for these experiments with millions of users that they would for their early stage products. Exactly the same thing. And it's because startups have one huge advantage, is that they have potential, they have upside. And they shouldn't be looking for those 0.1% wins. If you are a startup and you're trying to find 0.1% wins, you are not going to succeed in the long term. You need to be looking for big opportunities, 20% wins, 50% wins. These are low-hanging fruits. These are big changes you're doing to your product. You're not fine-tuning colors. And while big effects are very unpredictable in terms of direction and magnitude, so experimentation can help in there. Even the ones that are obvious, it's still important to quantify it. It's still important to know, how big of a win is this? What are the side effects that are happening? And it's because ecosystem effects are often complicated. I have the formula in the upper right is actually the sample size power. What you would do before an experiment if you wanted to determine how many users you have in an experiment. You need to make sure it's well powered. And the n is the number of users, sigma is the variance of your metric, sigma squared is the variance of your metric, and that delta squared is the effect size you expect to see. And if you're doing a Bing 50 Shades of Blue experiment, that effect size is going to be 0.1%, somewhere in that realm. But if you're a small company, that effect size is going to be like 10, 20, 30%. You'll notice that there's a squared term on that. That is why this is actually far more important than the number of users. There was another paper published by some folks that actually analyzed what happens if we look at startups who are running experiments. Or do we actually see that they have meaningful performance? So this paper did an analysis of 35,000 startups over 4 years. And they did they basically did an analysis where they controlled for all sorts of factors that would affect a startup success. And even after correction, they were able to find that the ones that adopted A/B testing on their website had increased performances, about plus 30 to 100% after 1 year of adopting it. And this is a really good paper to see. We can, from our customers, we can sort of see that we are seeing that they're able to, for example, just stopping the bad changes is already a huge win for your companies. There were several other things that this paper had sort of cited, that those companies were actually able to build and iterate products a lot faster, about 10 to 20% faster. And they firmly believe that this is because of a culture that starts to get introduced of idea generation. And this effect actually compounds over time. The companies start becoming better over time. Another thing that we find that our customers often ask about is listen, I'm a data scientist. I want to control for every single factor. But now my team wants to run more than one experiment. We want to run 2 experiments. How do I handle this? And the gut instinct for most scientists is, let's keep those experiments apart. The users in experiment A should not be the users in experiment B. We say this is not, you don't overlap the experiments. But it's important to keep in mind that an app like the Facebook app has 10,000 experiments running on any given time. Users are assigned to all 10,000 experiments and have the potential to interact. And the reason why that they've decided to do this is that if you carved up your user base 10,000 times, your sample size starts to become really small. Your experiments now take much longer to run. You have hurt your experimental velocity and your pace of innovation. And in this game of experimentation and innovation, velocity is really important. So my recommendation to most folks is overlap your experiments. It maximizes your experimental power. It can introduce noise, but controlling for this sort of noise is, I think, it's not an effective use of your time. And I'll show you, because in my experience, interaction effects, when one experiment actually affects the results of another, are very rare. It's highly overrated. Strong interaction effects are exceedingly rare, and most times effects are additive and directionally accurate. So it will lead to the same product decision in the end. And the best way to really quantify interaction effects is to do a long-term holdout. So I firmly believe that controlling all these effects is an illusion. And just as a simple example, if you want to keep the purity of your experiments by keeping them separate, I'll let you know that your competitors may be running experiments on the same set of users. If you're Amazon, if you're Walmart, you got to bet that your users are also being experimented on by Amazon. So I think precision is sort of a false thing to chase after. It's better to figure out, this is really understanding a feature is a binary decision. Do you want to ship it or do you want to pull it back? I have some best practices for data champions I'll quickly go over. The image here is actually from one of our customers, Fiona Cummings from Dispatch Health. So she deserves the credit here for being the champion of statistical significance and using this metaphor. There are some, these practices come out of a paper that was published. And really about like, if you want to get started, how do you pick your first set of experiments? You should find something that's contentious. Find something where like people disagree on whether this feature is going to work. Half the people in the room agree, half the people think it's a bad idea. Already, no matter what the result of your experiment is, half the people will be surprised and have learned something. Also, it helps teach the team that data is really the objective decider here. Pick something that is impactful, that has high visibility. I recommend folks go for whatever makes money at your company. For example, if you are Facebook, the ads team is where you start with, because that gets noticed high up, that gets noticed by all teams. So basically teams that drive business value is usually where you start. Those teams typically already have data and metrics well established. Automation, I've mentioned, becomes very important. And also just keep continuing the drive to make experimentation standard practice. These are still a little bit about more my personal notes on sort of the keys to scaling experimentation and where I've seen a few data scientists trip up. And it's like, one is like, in the world of experimentation, there's always going to be statistical ambiguity. There's no way to guarantee you're going to make the perfect decision. So you should embrace it. Don't worry about precision. Worry about getting quickly to the right decision. Worry about making sure your method is transparent, that people understand things. And make sure things are accessible. Data scientists should not be the gatekeepers and the only ones running the experimental analysis. Data scientists instead should be the ones driving cultural change, teaching people how to use data, how to make decisions, being those guardrails, being the keepers of the data-driven culture. I'll just give a quick shout out that we have a booth here. We are a sponsor of PyData. Please feel free to stop by if you want to learn more about experimentation, and that using StatSig is free for individuals and small startups. And I'm always happy to chat about anything experimentation. I love to hear what problems folks are facing and how they've solved them. And I've put up here on the slide a few ways to reach out to me. But finally, I'd like to thank everyone for attending my talk, and I'll take any questions. Thank you.
Hi there, and thanks. That was an amazing talk. So to make 10,000 experiments run in parallel in practice, I mean, that's like Facebook scale, but another company, I would say like tens of experiments. What kind of recommendations do you have as of like application architecture to make these kind of things possible? And what have you seen that works and doesn't work? And what is the extra cost of doing those experiments from an implementation standpoint?
Yeah. In the back of my mind, there's like the steps of going from 0 to 1 is a big step. 1 to 4 is actually a big step. But then actually going past that, all the way to 10,000, it's actually close, more similar than you'd think. I think folks usually, like by the time you're running like half a dozen experiments simultaneously, your teams are already talking about data. They've already plumbed in metrics. They're starting to do analysis in a scalable way. What I've seen in the past, as a data scientist, and as someone who's had to crunch experiments manually, it's very tedious, time-consuming, often requires a full-time data scientist per experiment. So at some point, and I would say like 10 is definitely that number, like you don't want to keep building a larger and larger data science team. You want to start building the tooling in place that has the metrics, trustful metrics being plumbed in, that has a process that engineers can follow. In order to do it in a safe, standardized way. And also start, at that scale, I would also start worrying about making sure you have things like health checks, because it's possible that, for example, a metric is not coming in properly, or you may have a sample imbalance that may be something that the engineer did, set up the experiment incorrectly. I think like at that scale, and that's also the scale that the data scientist starts to step away a bit. And so you hope that you've provided things like best practices docs. You have engineering champions, engineers who you have taught all the principles of experimentation, and they are now driving that change within their company. That's sort of like.
Do you see like microservices are an architecture that is like good for these rather than like the monolith?
Oh, absolutely. So I think the way I view experimentation is any change should be tested. It's not just the big ones, not just the ones that users can see, like back-end changes. For example, like Stripe. They do a ton of experimentation on their back-end, and these are all at the transaction level. These are things that the users don't see, but they are things that you want to track and make sure that things aren't regressing when you make them.
Thank you.
Thanks, Tim. That was a great talk. I was wondering if you had any thoughts on this challenge that I often run into with experiments. In an early conversation, when we're designing an experiment with a stakeholder, usually present a menu of everything that we can feasibly measure, and we ask what's important for your intervention and what you call a success. And the answer I often get is everything. Like, we want to see everything, right? And I get worried about the multiple comparisons. How would you counter that request?
Yeah, that's a problem with when you have too many metrics. And like, now I want to see everything. So it's actually almost like a good problem to have. But when it comes to experimentation, it's actually complicates things for some of the reasons you've mentioned. I would always ask people, what did you expect to happen? Like, what was your hypothesis? Or you can even create that hypothesis after the fact, but like, what would you expect to happen? Like, what is the most immediate thing that would be the impact that would happen? And then what are the things downstream that might be more important to the business, might be related to that? And so the idea is to come up with ideally like 2 to 3 metrics that are absolutely critical for understanding, making the decision. But then inevitably, when you are in a room of people trying to look at the results, people will come up with alternative hypotheses and want to look at alternative ideas that might require new metrics to look at. And my personal opinion is that it's okay to look at those, but that shouldn't affect your original decision. Those can actually be confirmed in follow-up experiments, whether those ideas work. And so that's sort of a way to sort of bridge this gap between being statistically rigorous, but also being pragmatic.
Thank you.
Got time for one more question.
Hi, I was wondering, given your experience at StatSig, what are some ways to drive a collaborative and healthy culture between the data scientists and kind of like the data platform team? And what are some of the things that a data platform team can build to support the data scientists and running experiments, as you've discussed?
The data platform team I did not mention, but they are very central to all of this. Most companies, the data platform team owns the experimentation tooling. They also own the plumbing about being able to standardize metrics at their company, making sure those metrics flow into the experimentation system at your unit of analysis, which is typically the user. Sometimes it could be something different. For the Stripe example, it might be at the transaction level, but making sure that's plumbing in, making sure that's working, making sure the numbers are trusted, making sure that agrees with your source of truth, but also making sure that experimental results are computed efficiently. We just had somebody mention, like, you may be calculating dozens of metrics. That's important to be able to have that flexibility in an experimental setup. Those are all the things that I would just sort of recommend. Like, data platform is really the key part of this, and I've seen in a lot of companies, experimentation can be actually most of what the data platform does.
Awesome. Thank you so much, Tim. Let's give a big round of applause.
Thank you.